Delegating bypass for push protection allows you to define contributors who can bypass secret scanning push protection and adds an approval process for other contributors. Let's dive into this feature, currently in beta, and see how it works. Hey y'all, I'm Mickey Gousset, a staff DevOps architect at GitHub on the GitHub Fast Track team. My team goes out to companies and helps get them more DevOpsy with GitHub. If you find this video helpful, I'd love for you to like the video and subscribe to the channel. Every little bit helps. Now, on to today's topic. Now, before I get into the topic of push protection for secrets, I need to provide a little background and context. So how often are secrets getting leaked by repositories on GitHub? Well, GitHub has over 100 million developers and billions of contributions per year. We provide free secret scanning for public repositories, and every month we detect about over 100 of our own personal access tokens exposed in public GitHub repositories. And we see similar numbers for other large service providers. So what is secret scanning? Well, secret scanning is a security feature that helps detect and prevent the accidental inclusion of sensitive information such as API tokens, passwords, other types of tokens and secrets in your repository. When it's enabled, it scans for known types of secrets and alerts repository administrators accordingly. Now, secret scanning is available on user-owned public repositories for free, and organizations that use GitHub Enterprise Cloud with a license for GitHub Advanced Security can also enable secret scanning on their internal and private repositories. So, what gets scanned? Well, it scans your entire Git history on all your branches. It also scans descriptions and comments in issues, titles, descriptions, and comments in open and closed historical issues, title, descriptions, and comments in pull requests, titles, descriptions, and comments in GitHub discussions, and wikis. Now, by default, secret scanning scans for a variety of partner patterns, such as AWS access keys. You also have the ability to provide your own custom scanning patterns if you want to. Now, push protection is a secret scanning feature that is designed to help prevent sensitive information, such as secrets or tokens, from being pushed to the repository in the first place. Unlike secret scanning, which detects secrets after they've been committed, push protection proactively scans your code for secrets during the push process and blocks the push if any are detected. Once enabled, if push protection detects a potential secret during a push attempt, it will block the push and provide a detailed message explaining the reason for the block. By default, anyone with write access to the repository can choose to bypass push protection by specifying one of three bypass reasons. If they bypass a push protection block for a secret, GitHub will create an alert in the security tab of the repository, add the bypass event to the audit log, and send an email alert to organizational owners, security managers, and repo admins with a link to the secret and the reason why it was allowed. Now, if you want greater control over which contributors can bypass push protection and which pushes containing secrets should be allowed, you can enable delegated bypass for push protection. Delegated bypass lets you configure a designated group of reviewers to oversee and manage requests to bypass push protection from contributors pushing to the repository. If the request to bypass push protection is approved, the contributor can push the commit containing the secret. If the request is denied, the contributor must remove the secret from the commit containing the secret before pushing again. Members of the bypass list are still protected from accidentally pushing secrets to a repository. If they attempt to push a secret, the standard push protection workflow, it blocks the push, you choose if you want to bypass it by specifying a reason, still applies. Members of the bypass list don't have to request bypass privileges from other members in order to override a block. Okay, so now that we understand the theory behind how delegating bypass for push protection should work, let's go see it in practice. Okay, so we're going to start off the demo by first showing you my security manager team, and I'll explain why. So here we are in my organization, and so we're going to go to Teams, and I've created a team in here called Security Managers. And if I go into Security Managers, you'll see that I have one user in there called Mickey-Octodemo. That's not who I'm logged in as right now. I'm actually logged in as Mickey Gousset, but Mickey-Octodemo is one of my security managers. And so security managers are going to be the ones who have the ability to work with alerts through all my repos, manage security settings through all my repos, and who I'm also going to set up to have that dependency bypass, that delegating the bypass for push protection rules. So I have that team. So I'm going to go to my organization level settings and go down to, let me find the right spot here, code security, global settings. And here in code security global settings, I have configured the security manager's team. You can see that right here. So I have taken the team that I created called security managers and configured them as a security manager so that they have read access to all repositories. They have the ability to work with the alerts, work with security settings. So now let's go to the repository that we're going to be working with. And if we go to this one, and you'll notice in this repository that right now I actually have some secrets that were found in the code. But if we go to the settings for the repository, and we go to code security and analysis, if we scroll down, there's a couple of things to point out. One is secret scanning is enabled and push protection is enabled. Now, the default for push protection is usually anyone with write access. So that means if you have write access to it, then the default is you can bypass it as well. And you'll get a little alert and you'd have to say why you want to bypass it, and all of it gets tracked, just like we talked about in the slides. However, I want to control that only specific roles and teams can bypass it. So I selected specific roles and teams, and then here I added my security managers team that I created earlier. So this means that even though the user I'm logged in as right now, Mickey Gousset, has admin rights on this repo, I can't push a secret. It's going to still have to be approved by this security manager's team. So let's give that a shot and see how that would work. Now, I'm going to do this in the GUI, but this would work if you're using VS Code or if you're doing stuff directly from the command line as well. First thing we need to do, though, is we need a secret. So let's go out to GitHub. And let's go to my settings. And we'll go to developer settings, personal access tokens. Let's go create a personal access token that we can use. So let's generate a new classic token, enter in our password. And this is going to be testing push rules. And we will generate the token. Now don't worry, I'm going to get rid of this token before you have the chance to do anything with it. But we have a token now that we can use. So if we go back to our code, let's go make a code change. So let's go into the front end and let's go into this file. Let's just make a change. And you know what? We're just going to push to main because we can. So when I go to try to commit this directly to main, pushing it into GitHub, I get this error message showing me that, secret scanning has found a personal access token on line 8 of my code. Either remove it or I can request a bypass. So I am going to request a bypass. So it takes me to this screen where I can say, it gives me information on where the secret was detected. And I can say, but I'm using this in a test. So I am using this to create a YouTube video. And I'm going to submit my request. So at this point, I've submitted a request and I'm waiting for it to be approved or rejected. Now, on the back end, anybody who's now in that security managers group would have received a notification saying, hey, somebody has requested to be able to push this code. So I would have gotten that notification. It would have had a link in it that would let me go to the request to be able to approve or reject it. Another way I can get there is if I go to the security tab. You'll notice that there is my request. Bypass push protection, get a personal access token submitted today. So there's my request, the one I just did. This earlier one was one I did previously. Now, if I go in and look at this request, I can't do anything. It just shows the request is there. However, if we log in as Mickey Octo Demo, and I go to view that push protection bypass request, which again, I would have also gotten a link in an email I could have clicked that would take me here. Now I can see the details of the request, the comment that I left, and I can decide, do I want to approve this or deny it? Now, in this case, let's say I approve it. So I'm going to approve this request. So it now shows that this request has been approved. So as the person that created this request, so if I switch back over to be Mickey Gousset, as the person that created this request, I now have the ability to push my changes. So if I come back over to this tab, I now have the ability to push my changes, or if I was in VS Code or the command line, I could push my changes. I would have gotten a notification saying whether it was approved or rejected. But now I can come in here and I can say, okay, let's commit this change. And it lets me push the change through. Wait, so let's go back over to security. And so we can see that because it was approved, that is what let me actually push that change through. If they had instead rejected it and I tried to push that change, then it would get blocked because the bypass request had been rejected. And there you have it. There's you an example of how this delegating bypass to teams or to certain groups, teams or roles, works. It's great because it allows you to have a more controlled aspect of who can override these rules, but at the same time, it is adding a little more process to where that security team might be a bottleneck potentially in getting your changes in. So I'll be interested to see if you decide to use this. Oh, and one more thing. So let me show you how I got here. So back at the organization level, if I go to organizational level settings and I go down to my audit logs, we can see that everything around this has been captured as well. So for example, I tried to push. Let me hold on a second. There we go. So for example, here's the alert, or here's the audit log where I tried to push and it got rejected. Here's where I submitted the request. Here's where the request got approved. Here's where I bypassed push protection for a secret used in tests. So that's what my actual push happened. Then what happened is, because it was a GitHub token, it got sent to GitHub, and GitHub, it created a secret scanning alert, and then GitHub checked to see if the token was active, and because it was active, it revoked the token, and then it resolved the actual alert. So here you can see, if I go to the alert that was created, it's actually been closed because as soon as I did that push, GitHub detected that that was an active personal access token, and then it revoked it. So just one little extra bit of information I wanted to give you. There you go. As you can see, delegating who can bypass secret scanning push protection allows you more control over who can override your process. But remember, it's also adding extra process into how you develop software. I'll be interested to hear if you utilize this functionality or not. So, drop me a comment below this video and let me know if you plan to use it. And don't forget to like the video and subscribe to the channel to help me with the YouTube algorithm. Thanks for watching.